topics, type 1 and type 2 errors. Here we go. The first scenario there that I copied out of a text was just to give you some more notes to go over. When we last spoke about type 1 and type 2 errors, type 1 errors occur when the null hypothesis is true. So you have to be making a mistake when the null hypothesis is true. Type 2 errors occur when the null hypothesis is false. So you have to make a mistake when the null hypothesis is false. So let's look at what we got here. We got a particular compound in drinking water that's not hazardous if it is present in 27 parts per million or less. An environmental watchdog group believes a particular study of water does not meet this criteria. So the null is that the compound presence is less than 27 parts per million. The alternate is the compound presence is greater than 27. So what's a type 1 error? A type 1 error is if you rejected that it's less than 27 when it actually is less than 27. Now, some people, sometimes they think, oh, well, it's an error to not reject 27 when it is less, or to reject, it's an error if you reject the something that's true. If it's less than 27, which is true because it's a type 1 error, that means that you should not reject it. You should accept that it's less than 27. So if you reject it, you're making a mistake. So therefore, that's a type 1 error. A type 2 error is when the null is false. So if it's actually greater than, you really should reject it. But if you choose not to reject it when it's greater than, you're making a mistake. So in a type 1 error, you should accept that it's less than 27 because that would be considered true. And instead of accepting it, you reject it. And in a type 2 error, since it's greater than 27, you should reject it, but you don't reject it. And to don't reject it is a mistake. All right. So to me, that's the best way I can explain it. God, I wish I had another way to make everybody happy, but that's the newest way to explain it. And hopefully I see the tests all go to 100% correct on this kind of question. Okay, next up, find the degrees of freedom. Well, this might be the easiest question on the entire test because all you do is look for the number of categories or columns on this particular chart here, and you got number of pets doesn't count, but the numeric columns, 1, 2, 3, 4, 5, 5 columns minus 1. You always take away 1 for degrees of freedoms, and you get 4. It's the number of rows minus 1. And don't count the heading row, just the number with quantified rows. Okay, number 16. Your company sells exercise clothing and equipment on the internet. To design the clothing, you collect data on the physical characteristics of your different customers. You take 27 male runners. It's close enough to 30, I think, to use a Z-test. You find their mean weight to be 61.49 kilograms. Assume the population standard deviation is 4.1. Based on this confidence interval, does a test of the null hypothesis that it equals 61.1, and the alternative is that it does not equal, find the value of P. So, since I'm doing a confidence interval test, I go to stats, I go to test, it's a Z-test, we go to the first option. The null is 61.1, the standard deviation is 4.1, and then we got X bar is 61.49, and the number is 27. So, choose the option that it's not equal to the null. When you do that, you get P is equal to 0.6211, 0.6211, and that would be the value of P. So that would be your answer. Okay, number 17. Last year, the government made a claim. You know what? I only have 17 and 18 to go. I'm going to do those in the next video.